All right, philosophers, let's start with part two of propositional logic. Last time we talked about propositional logic being taking propositions that already exist and kind of putting them together with these things called connectives and making new propositions out of them. And the one that we did last time was the if A then B or if P then Q, right? Hypotheticals. This time, however, we're going to use two different ones. We're going to use disjunctive. We're going to do disjunctive and conjunctive syllogisms. And so the first one we will do is disjunctive. A disjunctive proposition is an either-or statement. So A or B, right? I accidentally used capital letters here, and well, that's actually okay because sometimes you will use capital letters to symbolize the fact that it could be a proposition or it could be a formula. One of the things that's interesting about these connectives are they're iterative. So what I mean is that is like you could keep making new propositions onto infinity. So for example, I could say if P then Q, then Q, right? If it's the case that if you're alive, then you're breathing, right? And I could keep going like that, right? So A could be a formula, or it could be a proposition. I don't know about every single time, but a lot of times, people will use lowercase letters to symbolize just like one proposition, not a formula. So like I've heard it called proposition parameter. I've heard it called different things, but yeah, just one proposition, and then the capital letters to say it could be a formula or a proposition. So that's okay. But A, and it may look like a V, that's actually called a wedge. A or B. Excuse me. A or B, and if you're saying something like this, if you're saying A or B, then what you mean is at least one of these two things are true, right? So either A is true or B is true. Now, imagine the way I say that. At least one of these two things are true. Does that mean both of them can't be true? Not by the way I said that, right? At least one of them is true. So A or B, you mean A is true, or B is true, or A and B are true, right? That might sound a little bit weird because in English a lot of times we use the or, and we imply I can't think of the word. We imply that we're saying A or B, but not both, right? A qualifying phrase. I don't know what you'd call it. So, but we don't do that. We don't actually say that, right? We say, for example, your mom might tell you, you can either go to the mall or you can go to your friend's house. And when she says it like that, she's giving you two options, and you can only choose one of them. Now, in everyday life, you get that, right? You understand that. When she says that, literally speaking, that's not what it means, right? Literally speaking, it means you can choose at least one of those things. But when you think about, like, when she says that, why does she say that? Well, because she's trying to communicate to you that you have only one option. So using I don't know how complicated I want to get into this. If you're interested in this, you should check out Paul Grice's Rules of Conversational Implicature, right? As to why that is the case. But just suffice to say, like, you're not going to get off. Let's say your mom says that to you, and you actually go to both places. Trust me when I say she's not going to be impressed if you say, well, literally what you said was I have at least one choice, and I chose both of them, right? That's not going to work. So A or B, and we say at least one of them is true. That means if you know that one of them is false, the other one must be the true one. So A or B, the way to get a conclusion out of that is to say not A or not B, and then you get the other one is true. Therefore, not A, therefore B, or not B, therefore A. So that is a disjunctive syllogism. Here's an example. Either you're going to pass this class or you will fail it, right? So there are two options. You are going to pass this class, you will fail it. Right? You're not going to fail this class, so not this one. Therefore, you will pass it. Now, you may wonder, like, if I change, let's say I'm changed from not going to fail this class to you will pass it, right? Either you are going to pass this class or you will fail it. Instead of saying not B, I'm saying actually A. And then, therefore, you will not fail it, and so it's therefore not B. So the way this looks is A or B, A, therefore not B. And that's something I just said that we can't do. So you may wonder, why in the world did you do it just now? Well, this is actually the only reason this sounds valid, and it is kind of valid, but the only reason it sounds valid is because B really means not A, right? So either you're going to pass this class or you are not going to pass this class. That's kind of what you will fail this class. That's just what it means, right? Now, when you say A, it's the same thing. I didn't teach you about negations yet, but it's the same thing as saying not A. Kind of like a double negative, kind of, not quite. But it's not the case that it's not the case today, right? So that equals, that's the same thing. It's logically equivalent to saying A. So when I say A or not A, it's like me saying not A. And not A is this option right here, right? So not A is to deny this one, right? You're denying, if we wrote it out like this, A or B, you're denying B, right? So let's say A equals lowercase a, and B equals not lowercase a, right? Saying not A is the same as saying not B over here. And that's what we said did work. So therefore you will, therefore you will not fail it. So yeah, there it is. Here is an example of why, however, you can't say A or B, A, therefore not B. Either you're Clark Kent or you're Superman. So right, so this is A or B. You are Clark Kent, so A. Therefore you are not Superman, therefore not B. No, it's a true statement to say either if let's say you're Clark Kent or Superman, you're both. It's true to say that you are either one or the other, and you happen to be both. So saying that you're Clark Kent doesn't deny that you're Superman. It just affirms one of those. Therefore, the only rule we have for disjunctive syllogisms is that of affirming an alternate. Alternates are the two options you're given, A or B, and you can't say A or B, affirm one alternate, say yes to one of them, and then get any conclusion out of that. All right, conjunctive syllogism. This is both and. So P and Q. And what can you get from P and Q? Well, you can conclude P and you can conclude Q from that. You don't have to conclude both, by the way. I mean, you could just pick the one that you want, and then you'll be fine with that. But P and Q, therefore P, therefore Q. An example, you are both Clark Kent and Superman, therefore you're Clark Kent, therefore you're Superman. This may seem like just incredibly obvious, so why in the world is this even part of logic? Well, here's why. Because there's also such things as negative conjunctive syllogisms. In other words, when you negate P and Q. So, for example, I didn't eat bananas and peanut butter. What does this mean? Does this mean I didn't eat bananas? Not necessarily. Does it mean I didn't eat peanut butter? Not necessarily. What it means is either I didn't eat bananas or I didn't eat peanut butter or both, right? All you're saying is you didn't have the two of them together. That doesn't mean you didn't have either of them. That might mean you didn't have either of them, but it doesn't necessarily mean that you have either of them. Yeah, and here's sort of what it looks like. It's not the case that both P and Q, that's a negative conjunctive proposition. Not the case that both P and Q. What can you conclude? What can you say therefore? What can you conclude? You can conclude either it's not the case that P, or it's not the case that Q, or it's not the case that both P, not P and not Q. Really, there should be parentheses around here, but that's not a big deal. All right, so that is those are the things that we're going to be talking about. let's do a little bit of practice. Now, when we do this practice, I have to say that I don't have my stylus with me, so, and my stylus stinks anyway, so I'm going with fingers, and let's see if it works. I don't know. All right, let's do the same thing we've been doing. We're going to symbolize, and we're going to say if it's valid or invalid. Of course, there's only one rule, so it's going to be really, we're not going to say rule number 1 or rule number 2. First one says, either you're going to wear red or green. You will not wear red, therefore you will wear green. So what does that look like? Either red or green, R or G. You will not wear red, not R, therefore you will wear green. Therefore G, that is valid. I'll go ahead and try the next one. Either you're going to a party or you're staying at home. So either P or H, home. You can't go to the party, not P. Therefore, it looks like you'll have to stay home. Therefore, H. That is also valid. You can either get, dentist appointment. Dang, I have a dentist appointment in 2 hours. Oh, that stinks. You can either get the grocery. That's totally random. I hope Radiant Smiles is yeah, great dentist place. Check it out. You can either get the groceries or cut the lawn. So either G or L. You got the groceries, G, therefore you did not have to cut the lawn, not L. That is invalid. Notice you're affirming an alternate. You may either go to the mall or to your friend's house. So either M or F, friend's house. You chose to go to the mall, M. Therefore, this is the one that we were doing before. M or F. That doesn't sound right. And this is all kinds of crazy. M or F, M, therefore not F. Again, that is affirming an alternate. So that is invalid. Both vanilla and chocolate ice creams taste good. So both V and G taste good. Therefore, vanilla ice cream tastes good. Therefore, V. Now, one thing to notice about this one, by the way, you might be the kind of person that actually likes swirls, but you don't like vanilla ice cream. So when I say both vanilla and chocolate ice cream tastes good, even though it's the exact same semantic structure as if you mean that both of them taste good together, or you mean each one individually tastes good, here, I guess I should say, since it does make a difference, then you kind of have to know what this person means, right? And if they mean both vanilla tastes good and chocolate ice cream tastes good, then you can easily get the conclusion. But if they mean that both vanilla and chocolate, I don't know why I use G, both vanilla and chocolate ice creams taste good, then instead of saying V and G, you would have something more like, B, therefore vanilla tastes good, therefore V, which is clearly invalid. So yeah, so it's kind of weird. The word and here is oh man, I can't think today. This is what's called an amphibole. An amphibole is when the grammar confuses you. So due to the grammar here, I'm not sure if you mean that both of them taste good or if each one individually tastes good. If I said both vanilla ice cream tastes good and chocolate ice cream tastes good, then I would have no questions. If I said both vanilla and chocolate ice creams together taste good, no question. But here, it's not clear what you mean. Bill must be a U.S. citizen because let me okay, so you can see it. Bill must be a U.S. citizen because only U.S. citizens are allowed to vote, and Bill has a voter registration card. This is not a conjunction or a disjunction. This is one of our categorical syllogisms, and actually you could put it in like the if-then format, but let's do it like this. So Bill must be a U.S. citizen because, now this because right here lets me know that what I saw before this was the conclusion. That's supposed to be there. Oh man. What I saw before this was the conclusion, and so what I see after this is going to be the premises. So only U.S. citizens are allowed to vote. What does that mean? That means something like this: all voters must be U.S. citizens. Notice it's almost flipped around. Only U.S. citizens are allowed to vote, right? What does that mean? Does that mean all U.S. citizens are allowed to vote? No, no. It means that the only way you can vote is a U.S. citizen. So all V is U. Bill has a voter registration card. So what that assumes is all of Bill is a voter, right? Therefore, all Bill is a U.S. citizen, right? And that is valid, by the way. And you could rewrite this as hypotheticals, though. By the way, so only U.S. citizens are allowed to vote. So if you are a voter, then you are a U.S. citizen. Bill has a voter registration card. So if you have, let's see, what would this be? If you are Bill, right, then you are a voter. So if B, then V. If V, then U. Therefore, if B, then U. Right? There you go. All right. We don't have cookies and cake here, so you can't get any cookies from us. So let's see here. It's not the case that we have, let's say O is for cookies and A is for cake. Therefore, it's not the case that you can get any cookies from us. That is invalid. That's the negated conjunction. It's not a rule, I guess, but that's just invalid. What about the next one? Only the A students are able to achieve success. For only those who have above average intelligence are able to succeed, and A students have above average intelligence. Looking at this 4 right here, that I just destroyed. Let me use a highlighter instead. This 4 right here, I can't see around my own fat fingers. This 4 right here is the same thing as saying because before. So it lets me know that this thing, I'm about to get reasons for what I just said. So this thing is my conclusion, and what comes behind it is the premises. So, and again, this isn't a conjunction or a disjunction. So only those who have above average intelligence are able to succeed. So all succeeders, let's do is. All S is above average intelligence, let's say I. And A students have above average intelligence. All A students is above average intelligence. Therefore, all success achievers are A students. And this is invalid. It has a undistributed middle. So I think that's rule 2, something like that. That we said. All right. If it ain't broke, don't fix it. It ain't broke, so don't fix it. Of course, these are hypotheticals. If it ain't broke, if not B, then not F. It's not B, therefore not F. And that is valid. This is modus ponens. Notice what we have here. Let's change some colors. What we have here, not B is the antecedent, right? So that whole thing is the antecedent, and not F is the consequent, right? So it's not like you're negating something. You're actually affirming something. You're affirming you're affirming the antecedent. That's good. Either Donald is not here, or Mickey is not here. So either not D or not M. Donald is not here, not D. Therefore, Mickey is here. Therefore, M. Remember what we said that? I'm using the same knots. Oh man, I'm sorry. I'm so used to using those knots instead of the tildes. Remember what we said before about saying just like one letter. It's the same as saying not, right? So it's like saying not M, and not M is this right here, right? So it's like that. And D is the front one. So you're or not D, excuse me, is the front thing here. So you're affirming not D by this right here. So this is invalid. You're affirming an alternate. Even though there are knots there, this is you are the first term is not D, right? So you're affirming that. All right, and one last thing before we go, I want to show you is what about you could have made a mistake here. You could have said it's not the case that D or M, right? It's not the case that Donald or Mickey is here. And if you were to say that, you wouldn't be able to apply the rules that we came up with. Let's see what happens if you say that. It's not the case that D or M. Well, what does that mean? That means, remember, D or M means at least one of these is true. So it's not the case that D or M means that it's not the case that at least one of these are true. So it must be the case that both of them are false. So you can conclude that from that, therefore not D, and therefore not M. And then you could put that together and say not D and not M, right? And then, in other words, these two things are equivalent. Let's erase these guys right here so you can see them all together. So in other words, these two, I'm going to write an equal sign, a really ugly equal sign. In other words, these two things are equivalent, saying not the case that both D that D or M is the same thing as saying not D and not M. Funny enough, let's say we were to give our negative conjunctive again, not the case that D and M. Really, if I say it's not the case that D and M means that both of these things are true. So if it's not the case that D and M, that means at least one of those two things are false, right? So that's the same thing as saying either not D or not M. Ooh. So these two things are equivalent, right? Saying not D and M equals not D or not M. It couldn't, remember, saying not D or not M is the same thing as saying, look, at least one of those two things are true. So at least not D is true or not M is true, but possibly both. Possibly not D and not M are true. So what's kind of funny is not D or M that you see at the top equals not D and not M. And then not D and M that you see at the bottom, which looks like the same form except you're flipping, right, is the same as not D or not M. So it's almost like if you're going to do this, if you're going to negate a conjunction or a disjunction, I'm trying to get this thing up and I can't. If you're going to negate a conjunction or a disjunction, you do the same thing in both cases, only the ands and the ors are swapped. All right, anyway, that is it for today.